Hi all, so I've been following this amazing series on making your own 3D graphics engine by JavaScript 9, also known as One Lone Coder, and I've already dropped a couple of videos covering like the end results of the very first two parts that he has made. And obviously, like, my tutorials are not even trying to explain things because I can barely understand this on my own. But what I was trying to do and what I dedicate my work to is try to make exactly the same thing but in JavaScript, and so that it runs directly in the browser. And this part 3 was the place where the true challenges had started taking place. So in this video I want to tell you a true detective story about the lost triangle. Okay, so just to give you an idea, like, what is so interesting about this story, why this is so exciting, because I've been debugging this for 2 entire days, and I almost lost my hope to, like, get done with this ever. So, just to give you a clear understanding of what kind of task I was facing, so what I was doing in particular, this would probably give you a bit more clue in terms of, like, why I was so confused, like, in regards to the lost triangle, what the triangle was actually lost and why. So this part here, so you see, like, this the triangle clipping, like the timestamp here, and there are 2 types of clipping within this engine in particular at this stage in particular. So the depth clipping and the I'm not quite sure how that's named properly, like when, like, the edges of the screen clipping or something like. So I got stuck at the depth clipping, and here is the idea. So I would probably rather go to the source code. I can even go to the original source code. I will then get back to my source code, which is a little bit different because apart from this issue I have a couple more. So I was forced to change, like, alter the code a little bit to make sure that I can divide and conquer every single part, and, like, to track the potential possible issues. But anyway, what I really want to show you is called the function responsible for actually clipping the triangle. So triangle clip against plane, that's what I'm interested in. And here, so, like, just to give you an idea, what is this all about? So to make sure that when you approach the object too closely, like, nothing gets wrong with the geometry, so that's one of the reasons to do this clipping. Now, the interesting thing is how in particular are we doing this clipping indeed. Like, so we have 4 possible outcomes here. So I will quickly walk through the first and, like, the first 2, which are not really as important for us as the last 2. But just to give you an idea, so the first scenario, so if all the points are on the outside of the plane, so clip the whole triangle it's easiest to exit. If the points are outside of the plane, like here for instance, 1, 2, 3, so this is the triangle, so it's outside of the plane. In this case, you just ignore it and not drawing it, so just return. So no triangles are supposed to be rendered in that case. So like, we are putting into the function the triangle, the input triangle, so which, if otherwise nothing is done, it would be drawn anyway with just some crazy polygons across the screen. So let's say triangle lies like outside of the plane, it gets ignored. The second scenario, when we have that within the plane we have all of the dots, like all of the vertices are within the plane. In this case, the input triangle just gets copied and stored for later. That's also clear, that's fine. But 2 scenarios we're truly interested in are the following. Like the plane like this. So 1, like 1, 1, 2, and 3. So in this case, if you draw the triangle, so from this one it goes here, from this one it goes here, and then it just connects outside of the plane. So this case is very simple because we already have the triangle and like this. So all we need to do is to make this big, like this one big triangle, We just need to make it small like this. So this is what this outcome kind of results in, like making the triangle smaller. But the most complicated and the source for the lost triangle scenario comes in here. So this is the case where 2 points lie inside the plane while the third one lies the outside. So you just see the following way. So I have 1 point, I have second point, and I have the third point somewhere in here. So in this case, if I draw it like this, this is the triangle. But if I draw it like the way we did before, so here to here, and then here and here, so figure like this. So it's no longer a triangle, it's a quad. And to represent the quad, we actually need 2 triangles, to make sure that both of the triangles are being displayed properly. And what one lone coder does here, so he just so those triangles formulate in a quad, he gives them different colors to make sure that he can distinguish each one in separate and drag them as well. So that's how it works. So we need to actually calculate the vertices for these 2 triangles, and this is what happens within this part of the outcome when the outside the outside point count is equal to 2 while the inside is equal to 1. And this code, I have this code being duplicated, ported to JavaScript. It works. I thought that maybe the problem relies in here, but no, it works. And it does indeed return 2 triangles, and when we draw those triangles to screen, so they should have been drawn. Now, one of the biggest challenges was actually to figure out whether I had no idea where the bug is. So I was tracing every single part of the code possible ever to make sure that I can locate properly where exactly the bug is occurring. At the very least, if I don't know for sure where exactly it happens, I can at very least say where everything 100% goes just fine. So after this extensive debugging, I figure out that in bytecode in particular, the function to clip triangles, this one, triangle clip against plane, so this works nicely for me. So so in case if we have the visible triangle, so this if statement, you just don't need to care much about what is this in particular and how exactly. So here we have 2 scenarios. So we are calling the routine to do the depth clipping for us. So this happens in here. And the clip triangles variable gets the number of triangles that has been returned. So just to give you an idea, this return values are quite important. So for instance, because it was originally using the for loop, but never mind. So it returns 0, we don't need to draw anything, which makes perfect sense. Then if we duplicate the original triangle, it returns 1, so we need to render only 1 triangle, which also makes perfect sense. If it just minimizes the triangle, so it literally the big triangle becomes a little triangle, so 2 points outside, 1 point inside, so just 2 points comes from here to make sure they fit the plane. So we still have only one triangle to render. But there is one place in the code, which is this one in particular, where we do return 2 newly formed triangles which form a quad. So again in the video, it's this one, this quad here, green and red. So these 2 triangles are stored within the clipped variable. So clipped has 2 triangles in it. So if we don't have a quad, so in all the scenarios other but these where we return 2, then this our triangle 1 is literally the pointer pointing to the clipped index by 0. So the first triangle is stored at the clipped variable index by 0. So that's where the first triangle lives. And every single time we do initialize the first triangle either directly in here or altering it, but still it's the first triangle. And even here, the first triangle also being initialized, but also in this case we also initialize the second triangle. And that's where the mystery is coming in. So the second triangle also like is stored as clipped 1, indexed by 1. So clip 0 the first triangle, clip 1 is the second triangle. And then so in case if we have only one the clip triangle variable is equal to 1, which means we have like only one triangle to render at a time. In this case, we just call this add triangle function, which we now come to this. And then this, in case if we have this quad scenario where the 2 points lie within the plane, but the outside point lies outside of the plane, so we have in the quad. So in this case, we need to add, instead of just adding one triangle, we need to add 2 triangles, and that's quite important. So we are adding 2 triangles here, and I'm giving these triangles different colors. Well, probably not exactly the same as one lone coder did, but at least to distinguish these two, because the colors don't matter on their own. So just we need to make sure that we can distinguish these two. So we're adding these triangles. So which means that the function add triangle. So let's go to the add triangle function now. So the function add triangle, what it does? So it does all the scaling with either triangle, either clip 0 or clip 1. So this function makes all the scaling to make sure that when it comes to actually rendering the triangle to board, we have the exact particular 2-dimensional coordinates, like where exactly to draw this, because that's the input to our draw triangle, right? So which is just the commanded one. We'll come to this a bit later. So like this filled triangle, like we literally need to draw like 3 dots on the 2-dimensional plane. That's the HTML canvas specific thing, and then we just need to fill it with a fill. But anyways, it's not really that important now. So what happens then? So once we've created, so like a triangle projected is a piece that can be drawn like this or like this or like this. So literally, so although it looks like 3D, and yes, you can even move here. So just to give an idea, so that's like camera is moving. So I've also loaded these axes just like in the original tutorial. So yes, if you're far away from it, it's just quite pretty, nothing special. But if you come closer, if you come really closer like this, in this case, this clipping takes place. So let me continue, please. So triangle projected is something that gets stored for later. So the reason for instead of drawing them instantly but storing for later is because we need to make sure that the order of how likely triangles are about to be appearing on screen should be verified properly, so that first we draw those from back, and then those closer to the camera, because otherwise I will now show you what is going to happen otherwise. So, and here finally, I'm sorry for such a long introduction, but otherwise you hardly understand my joy and happiness after figuring out what was wrong here in particular. So now you consider the following thing. So this part of the code is just for debugging purposes. Just draws the outlines like blue here. So let me just get rid of this one as well for now, because just to give the full picture, it will still be drawing these blue lines, but these blue lines drawing happens into different places. So now you see, like here we don't have a blue line, but before we had this code commented out, we actually had one. So now we have this triangles to raster list, which has all the triangles we're supposed to be drawing, and here down below, yeah, just hold on a sec, let me so here yeah, so after we did add all the triangles we were interested in, literally, then we do the following thing. So we loop over all of the triangles we've just pushed to this triangles to raster list, or range JavaScript, and then we do the sorting. I'll now demonstrate what happens if we don't do that, and then we draw these triangles, right? So just to give a quick idea what happens if we don't do sorting here. So I just update, and you see like the order in which triangles has been rendered is horribly wrong, so it results in this sort of thing. So although the geometry is proper, but like the order is wrong, hence it's not really like good to work with. So you see like it just like not being rendered properly, like just the wrong way. So in order to avoid this kind of scenario, what we need to do, we need to sort the triangles. So in this case, we have everything being done properly, and we have like everything is just fine here. But here is another issue. So we have just added all the triangles, but for some mysterious unknown reason, it just happens that where we should be having, like in the scenario when we have in a quad, so this is the quad in particular, so this vertex, this one, and this one, so this forms a quad, but only the one of the two triangles is drawn here. Now I've been looking for a way of how to debug it, and after hours of different trials I came up with the following thing. So let me just completely comment out this part that is actually rendering graphics to screen. So now it should be just a black screen, nothing else, right? And now if I just go back to my to this part here, so if I just so what am I doing now? Instead of pushing the triangles to this triangles to raster list or array, instead, well, I still push them, but I no longer use this variable. So I'm directly rendering them once I'm encountering a triangle. So the reason for doing this is just to make sure whether the problem with the missing triangle is we didn't calculate properly the coordinates of its vertices. For instance, that might be one possible scenario. Or what else could happen? Or maybe we just don't call this a triangle, so it should be called, but it doesn't actually happen for real, or anything else. So I need to make sure, like, whether that triangle I'm looking for actually exists or not. Whether it has been generated or not. So that's the reason why I'm rendering these, both the fill and the outlines directly. So now it should be exactly as it looked like before sorting. So exactly, in particular, this looks this exact way. And here, suddenly, we see that our triangle is actually there. So we had only blue one the previous time, but we didn't have the green one, right? So yeah, the order is wrong, sorting doesn't work, but we can say absolutely, like 100% sure that this triangle does exist because it gets rendered. And now you just try to realize my confusion. So what happens is the following. So we do add, so this triangle projected, so it either gets added to the triangles to raster array, right? Or it just gets directly rendered onto the screen. But in the case if it gets directly printed onto the screen, it actually gets rendered. It is there. It is available. But if we just add this to triangles to raster and try to render it later, it disappears for some unknown reason. So just to give you an idea again, like how this works, or better to say how it doesn't work. So I just drop back and I uncomment. So here again we have the loop that loops over the triangles that are stored for later and then got sorted here. So I just do this again, and the triangle is lost. So where is our triangle, you might be wondering? And I was like cycling, like, I don't know, maybe thousands of times trying to figure out why this could be ever wrong. I was trying to make sure that the coordinates exist, the vertices exist, and things like that. But then suddenly an idea came into my mind. So what if, so it just, I was also doing another sort of experiment, just to show you one last experiment I've been doing. So here, for instance, if I had only one of them, so I was wondering like why it only draws the second one. So now the output should be exactly the same as before. So it should be drawing the lower triangle, and it does, right? I had another scenario where I could print only the first triangle, like in here, which is also good, but this time the second one was missing. But I could never manage to do them both, and I just uncomment, so they both should be rendered, right? But why the heck they don't? I was like completely lost at this point. The reason behind this is very simple, actually. I have no idea how in particular this is happening and why. I don't really think this should be happening, or probably if I delve in the code a bit more, I would realize why exactly this is happening. But what I can say for sure is that the pointer to the triangle projected gets override somehow when it gets pushed into the triangles to raster. So just to give you an idea, and just to prove you my assumption, I will now fix this nasty bug. I've spent a few days trying to figure out what's wrong. So what I will do now is probably not, like, first of all, it's not efficient. Secondly, well, definitely not the way to do things. But at very least, what I would do now, just right at the moment, would ensure that my idea, my assumption in regards to like what's happening, like, my assumption is that the pointer gets override for some reason, and that's the reason why seemingly two different pointers, two different triangles. They are supposed to be two different triangles, but they point to exactly the same coordinates. And I mean, in another test, I was trying to render them separately to make sure that I was thinking like maybe the triangle is lost. I can't reproduce this because I will break all of my code, but just to give you an idea what I was doing as well. So I needed to answer the question whether the triangle is actually lost or it exists somewhere else. And it turned out that it's not lost. Actually, so this green one, there is a blue one below it. Underneath this green one, there is the blue one. So I made some tests to figure that out, which gave me an idea that the coordinates, it's not the matter of losing the certain triangle. The triangle is there, so it gets pushed into the triangles to raster, so everything just goes right. But the problem is that the data source of where the vertices are that has been sourced to this the second triangle was exactly duplicating the coordinates of the very first one, which gave me again this exact idea. So the only reason why the coordinates might be exactly the same is we just it's like some accidentally the pointer to the second triangle points to exactly the same place in memory where the pointer to the first triangle is pointing to. Well, probably doesn't make sense if you don't understand what the pointers are. Like, for those doing this in JavaScript, you may not be that convinced, like not that likely into pointers, but anyway, hopefully this makes sense, at least for those who does like C or C++ programming. So let's fix the bug. Triangle projected on the lower level is just a pointer to the certain data structure. And this triangles to raster, when we push this kind of object into another object, it just literally on the lower level, I'm not quite sure how JavaScript works in the lower level, but that's assumption based on the user experience, the programmer's experience. So literally, we're just pushing the pointers. And when we're pushing the pointers, it might happen that the pointer one day would be pointing to some wrong place where it shouldn't. So in order to avoid this, we just create a new object before pushing this, and this would ensure that the pointers to every single triangle projected would be pointing to its very own place in memory. So something like this. So what we need to do in order to do this, there is a thing known as a deep copy, and one of the simplest, well, not most efficient, probably the least efficient, but very simple and very quick way to make the deep copy in JavaScript is the following way. So we can simply say json.stringify, And this turns the triangle projected data structure into a plain string, and then we need to pass it again. So here I just say json.parse, and like this. So now JSON parse returns a new object, and this new object has a new location in memory, and this time the pointer to that exact location is getting pushed to the triangles to raster. And suddenly, and okay, syntax error. Okay, yeah, now it works. And here is our lost triangle, guys. So yeah, it was just the matter of the overridden pointer that was pointing to the previous triangle for some unknown reason. But once we instantiated every single triangle projected object separately, it suddenly works nicely. So definitely it still needs a lot of debugging to make sure that I didn't miss anything. I'm not even near yet to complete this tutorial part 3, which is really challenging. I also need to add the clipping over the edges of the screen. But when I'm done, hopefully I would make a video showcasing the end result, and I would share the source code after I finish this. So now it's no reason to share the source code because it's really lots of things needs to be checked there out. That's it from my side, guys. See you later and cheers. Thanks for watching.